talk today is going to be about how can we visualize a high-dimensional data sets, and in particular, the data set that I'm particularly interested in is products. You can imagine that, you know, how do you go about finding a product that is interesting to you? Typically, we use a combination of search and maybe then reading some reviews and maybe using some similarity connections. And all of these have one commonality, which is they involve scrolling up and down, or they involve scrolling left and right. But my guess is that people like to explore in a more free situation, as long as the space that they're exploring makes sense to them. And so that's what I'm aiming to do. That's the project that you're going to see. And specifically, I'm going to do it for books. Okay, let's see. I'm supposed to be able to press, yeah. Okay, so about me, I have a PhD in economics. My bachelor was in computer science. I see myself as a programmer. But I'm teaching economics at Carleton College. That's what I do. Typically, just do stuff that is applied computation within economics. At Carleton, I teach macroeconomics, finance, and econometrics. And most relevant for the people in this group, there's a meetup that I lead every Sunday at 2. It's called the Twin Cities Deep Learning Study Group. You can find it on Meetup. And what we do there is we go over textbooks. The last textbook that we've been going over is Hands-on Machine Learning with Scikit-learn, Keras, and Tensorflow. We're about to finish it, so we will have to decide what we want to do next. We'll see. And I should say that people that know me know that I'm obsessed with a type of deep learning network called variational autoencoders. And so you can say that whatever I do, it's kind of ways of finding an application to this technique, variational autoencoders. It's a type of deep learning network, and so this fits right in. Like my goal is to find an application, so that's what I do. That's applied AI, yeah, by definition. Okay, so this project, what did I want to do? I want to have a visualization of the space of all books. Okay, so that's challenging. There's lots of books out there. I'm using Goodreads as the source for my data. And so the object is to scan a good portion of Goodreads. Then I want to provide a tool that will enable you to find a book that's of interest to you, maybe based on subgenre, maybe based on similarity to other books. My guess is if you manage to construct a space where every book's location really means something about what this book you'll see. And then I want to make it easy to know for any group of books what are the most popular groups within what are the most popular books within that group. For me, I often need to search for books for my daughter. And so in that situation, I need to know easily what is the appropriate age for a particular book. So that's a particular need that I have. And then on a broader scale, the idea is that we should have a visual exploration alternative to the regular search. Okay, so whenever you're trying to find products, whether that be a movie, whether that be a car, a house, you know, whatever product you're interested in acquiring, how about if we have some alternatives to the scroll up and down? Okay. So let's see if the demo works. Go to seethegalaxy.com. I'll put the link in the chat. That's the demo. And that's the product that I'm going to be talking about. At least that's the current situation of that product. Let me just paste the link in the chat. Now, as you all are going to go into this, we might have a little bit of a crash. And the reason is I'm serving the app from the same computer that I'm using for the slides, which was probably not that smart, but okay. Where is the, did someone already put it in the chat?
No, but I can go ahead and do it.
Here, I got it.
You got it, yeah.
Okay. Okay, so what do you see when you get in here? What you're seeing is a visualization of all the books. Each dot is a book. If you take your mouse and stand on any particular dot, you will see the cover of that book, followed by the top tags, top genre tags from Goodreads that apply to this book. Let's pick something that is well known, say the Da Vinci Code. So the top genre tag for the Da Vinci Code was mystery, followed by thriller, suspense, mystery thriller, and historical fiction. And then the last thing is you get to know exactly how many tags like this users applied for a particular tag. So say that you're looking for mystery books, then you'll color everything by mystery. A science fiction fan, so maybe I'll color by science fiction. And so now the coloring scale is according to science fiction, with yellow being highly popular, right? And so there's a couple of things to notice about this. Oh, and I should say, if you click and drag, then it will pan the visualization. And if you scroll inside, scroll up, I think, if you scroll up, then it will zoom into it. Okay, so you can have a closer look at the books. Okay, so now what's interesting here in this visualization, and the stuff that's probably, I'm going to turn off my video. I see that my video is coming in really bad. Just a sec. How do I turn off the video? Okay, so what you can see is that there is a location for every, if you play around with the coloring, you will see that every location actually has a particular type of books that are placed in that location. So horror is over in this area, while we saw science fiction is actually next to it, is over in this area. And so the algorithm decided, you know what, there's a bunch of books that are both horror and science fiction, so I better put science fiction next to horror, right? And on the other side of science fiction, the algorithm decided to put in fantasy. Where is fantasy? Maybe a little bit up. Here it is. So we had science fiction in this area. There's a little bit of an overlap between science fiction and fantasy, and specific, the type of overlap is primarily with stuff that has to do with time travel. There's a little bit of time travel over here. Let's see, I'll show it. There's big patches and there's small patches. So for example, time travel would be a small patch. Where am I looking for? Time travel. Here, time travel is within science fiction, but it's just this little sliver of science fiction. And this little island next to it is all Star Wars. And on the other side of this gulf, these are all space opera. Okay, so there's big genres, and then there's small subgenres that have been placed within them, and there's interfaces between genres. There's the interface between science fiction and horror, and then there's the interface between science fiction and fantasy. And you really have everything in this chart. There's when you load this thing in, there's just 60,000 books that are included so that your computer doesn't crash. But if you come down here, you can pull this thing all the way to the right and try to surf when there are 200,000 books on the chart, right? And so you get a really good picture of what's out there. Oh, and the other thing I wanted to say, I promised that not only genre would be encoded, but also popularity. The way the algorithm works is it places the stuff that is unusual out. And the stuff that is more common, it places it closer to the center. And so these things that are out there are things that are very, very popular. So for example, here are a bunch of books, all written by C.S. Lewis, right? These are all the Narnia books. And by the way, the algorithm didn't have a tag for C.S. Lewis. So it just inferred that they are similar because people apply similar tags to them. And it decided to make this little group for the books of C.S. Lewis. But the reason this book is out there is because of how popular they are. These are extremely popular books. The Harry Potter books are over here, right? You can probably see it a little bit.
This is Jen. I'm curious, how are you defining popularity? I'm sure it's coming through the data with Goodreads, but what defines popularity?
Great question. So one more thing that you can do is you can right-click on a book. If you right-click on a book, it will open that book in Goodreads. Okay, hopefully in reasonable amount of time. Here it is. That's Goodreads. The thing that I'm using for this site, the data that's coming in, is this genre tags. And Goodreads, the users on Goodreads, they apply tags to the book. So for each book, you can get, how many people applied the tag to read to this book? How many people applied the tag own? So I filtered these tags so that I only see stuff that is relevant for genres. And then I use these tags. And a highly popular book is just a book that received a lot of tags. It's been read by lots of people, and lots of people tagged it, say, as science fiction or as time travel. Okay, that's the source of the data. That's what you see in the coloring when you color something by a particular subgenre, which is helpful in, so there's two ways that this is helpful. You can first, there's like 333 different tags here. That could be a pretty, you could find a tag that is good for your taste and just look for the most popular things. You didn't need a visualization to do that, right? We can make a site that doesn't need a visualization. The interesting thing is the interfaces, right? So say that I like to read comic books. Okay, so if I like to read comic books, they are all over here at this part of the chart. And if I'm looking for picture books for my child, and I'll color it by picture books, we will see that picture books are a group by themselves, but they are close to the comic books. And of course, there is all kinds of books that are somewhere in between a picture book and a comic book. And if I zoom in this area, I'll be able to find them. Right, the books that the algorithm would place in that area between the two groups are books that are both tagged as picture books and tagged as graphic novels. Okay, so they are somewhere in between these two things, like this one. Okay, so the algorithm is basically generating for us situations where there are combinations of tags that are being encoded because of all these interfaces. Do people have any questions? It was pretty good that someone asked me a question.
I have a lot, but I can wait.
Go on.
What are the color represent?
The color represent the number of tags. So if I look for something that's yellow, right, I will end up hitting on a book that's highly popular. So Where the Wild Things Are in picture books, it's very popular, right? And Green Eggs and Ham, it's very popular. So basically the color represents how many people apply the tag picture books to each one of these books, right? And I make a cutoff. There's a, I go for the top 50 tags for each book. And so you see a lot of books that didn't get any picture book tags, and that's why they are sort of in deep purple, and you can't really see them. But if they got the picture book tag, then there'll be this little box in the bottom that says how many tags did they get when I last scanned Goodreads. Right. Interestingly, I mean, we just tried picture books. We see that there's a group of picture books over here, but there's also a group of picture books over there. Where is this? And so it's interesting because that group of picture books would have a different character, a character that's associated with this area of the chart. And this area of the chart has to do with biographies, right? So all of these are picture books that are either historical, tell a story about history, or are a biography. So there's some aspect of them that is real, and that's why they've been placed over here instead of with the rest of the picture books. Right. So that's exactly the kind of beauty that you get from an algorithm like that.
So Yaniv,
yep.
I don't know if you mentioned you're interested in thinking about, a product, and obviously you could look at a lot of different products. We could probably brainstorm about what other products, and probably more heavily attributed, would be preferred. But I wondered, maybe next level down, if you've ever considered something like the U.S. patent database. Most patents are fairly heavily attributed. They have a time attribute, when were they filed, when were they issued, when did they expire, that sort of thing. You have class codes associated with them. And I'm thinking, maybe there's some potential. Who knows? Maybe it's been done. A lot of stuff around patent analytics has been done, but it seems like you could get some interesting visibility with your variational autoencoder that might produce some visibility that hasn't been yet discovered around groups of like class codes, like different types of inventions. And we like to say that all the interesting stuff happens at the intersections. What might you discover, not only looking at single dimensions of class codes and maybe over time, but also looking at different combinations of class codes? I just have a suspicion you might discover something with your autoencoder. So
that's a brilliant idea. I mean, that sounds like a very exciting thing. I mean, I think that the number of applications we can think of here is the number of data sets that we can think of, right? Because all this thing does is takes a high dimensional data set and provides a visualization of it. And so this is, I have to decide what to work on and where to push the envelope. But yeah, patent sounds awesome.
Well, sorry, where I was thinking, like, what might be a commercial objective, or some kind of interesting economic opportunity. It seems like you could maybe, if you started to look at things over time, or looked at density of certain products, or classes, or certain intersections, you might be able to identify white space. Where are trends, where where has heavy activity been in the past, or might it be headed, and where is there white space that hasn't been very very populated yet? Can you predict directions? Some of the large companies might be interested in your prediction of territory that hasn't been civilized yet. So anyway.
Yeah, I agree. I mean, one of the first things that I've done with this algorithm is I try to market it. I try to convince people that this is how they should think about what should be the next product that they should come up with.
Beautiful.
Right?
Yeah.
Because there's an interface there. I still have some of the work that I've done there. And yeah, ultimately, I think this is for enterprises. This is a really, really attractive application, right? White space, interfaces, places where there's we can find customers that aren't being served at the moment. Yeah. Okay, so I
along those lines, I was going to say,
yeah?
there was just a quick question about how did you decide on this project?
Well, the data was there. I was, to tell you the truth, I was just, okay, so I was just really frustrated with Goodreads. Goodreads is an awesome site, but if you start looking for books in Goodreads, there's my particular issue was with middle grade books, and the inability to separate middle grade books for my 10-year-old from what I would say is young adult books. Mm-hmm. Young adult books would have you know, more violence, more sexual descriptions and or romantic intense descriptions, and I wanted to avoid that, and it's very hard to do in Goodreads. This particular thing almost solves that problem, so I will show you. First of all, I can go for a tag called middle grade, and the problem with that tag is there's overlap between this tag and young adult. Okay, and really I wanted to know when I pick something that it's also not that much of a young adult. So here you see middle grade, and I'll show you young adult in a second, and you will see some of the nice things. I can sort of verify an appropriate age because there's a spectrum over here. Okay, you can see middle grade occupied this area, but over here, these are more young adults. And so even within this area that was highlighted on middle grade, I know that the lower something is, the more young adult it is, right? And that allows me to know like what age is it appropriate. So I would start her off on stuff on this area, and we will, you know, we will slowly go down and be careful as we're coming down here. Artemis Fowl would be already a little bit too early for her. Or I don't know, let's pick something from here. And this is fine, but Neil Gaiman, I think, is too early for her. Okay. Yeah. So that was one of the motivations. Really, and cool. I should say, like, I work on generating encodings that are meaningful. I needed to do this on a data set where I have good intuitions, where I understand what is a good encoding and what is a bad encoding. And I know books, so that's why I chose books.
Good, makes sense.
Okay. Okay, so I promised to show a little bit from the text, from the tool stack. So let's have a little bit of a show of the tool stack. So I scraped the data with Scrapy. Then I selected the tags with SQL, PostgreSQL, to be more precise. The modeling was with variational autoencoders in Tensorflow. Then deployment is, and I would suggest this last step is something data scientists need to know how to do. To quickly deploy whatever modeling you've done as a rudimentary web app. And my recommendation is Flask. Is really simple to learn. And then there's this relatively new tool called Observable, which I just love, and I would love to share with you a little bit. So instead of using just regular, say, Plotly or Dash or stuff like that, Observable is an alternative, and it's like a Jupyter, but it's really, it will blow your mind. It's like a Jupyter notebook for JavaScript. Okay. Okay, so that's the tool stack. What did I want to do? Here's scraping data with Scrapy. What you need to do is you need to write like a file that tells Scrapy what URLs. This is Python. What URLs to start from. So, for example, there are pages that show popularity for any particular month or year for the last 100 years. For the last 2 years, it shows by month, and for the last 100 years, it shows by year. And so that's the source of the original book links. And then getting the data out of the page is as simple as looking for an appropriate CSS tag, right? That's how simple it is to scrape stuff with Scrapy. Once you write this file, all you have to do is you go Scrapy crawl. You tell it what is the class name of the class that you just defined, and where do you want your output. And it will spring up lots of parallel processes, and those are fault tolerant. So if you don't get the web page, it will try again a bunch of times. So it takes away a lot of the common things that you have to do when you're scraping data, which is just managing the connections. It's not beautiful soup. These tags are, these selectors are coming from Scrapy's itself, but they're not hard to navigate as well. Okay. And it's not as powerful as beautiful soup in terms of selecting stuff, but you could also always revert to beautiful soup if you wanted to. Okay, and then the output of this is you just get a JSON file with the data that was scraped for you. All you need to do now is just read it back into Python, which is super easy. Okay, then post-processing with SQL. So for example, I need to clean, right? I download all these shelves. For each book, I download the shelves information that you saw on Goodreads. Maybe I'll show it again for a second. Where is it? I think I closed it already. Okay, so for every shelf, there's a count of how many people. For every book, you can see the top 50 shelves. The issue is there's lots of shelves that you don't want. And so you need to come up with a list of the stuff that you don't want. And okay, so there's a long list. I'm not showing here the whole list, but that filtering needs to be done. And then the next thing you want to do is you want to rank. What are the most, what are the top tags that were applied to each book, and you want to make sure that you only, for example, you count here. I'm counting. How often was a tag used in the top 3? In the top 3 of the filtered stuff. Okay, so cleaning the data is usually very, very intense thing, but the interface that you're seeing here is this is an SQL query, but I'm writing it in a JupyThon notebook because that's the environment that I like to use and use to keep a record of my work. So I'm defining it as a string. Then I'm supplying it using a package that just makes a connection with a PostgreSQL server. And so I'm working in Python, but I'm writing SQL queries, submitting them to the database, and getting my data back either as a JSON or as a pandas. Okay. What else? Okay, modeling with TensorFlow. I don't know if I'll get deep into this. How much time do we have? Yeah, we have a little bit. So I would just say this is a variational autoencoder. Autoencoders in general are neural networks where the objective function that you define is, I give you data on the input, please provide as an output something that is as close to the input. So X and X prime should be as close. X prime is the output from the neural network. And then the way you get compression, in our case, we need a representation in 2 dimensions. And we're coming in with 333 dimensions, okay? And so we want to condense the information from 333 dimensions down to 2. And the way to do that is in the middle of the neural network, it has to transfer the data through just 2 neurons. Okay, the 2 neurons are the only way to pass the data from the input to the output. And so the first part of the neural network ends up being like an encoder, something that can reduce dimension. And the second part of the network becomes a decoder, something that can increase dimension back. And what you get from that, maybe there's a way for me to increase this, is you get a mapping that preserves local distances. So if a bunch of points were close to each other in a multidimensional space, after being mapped, they are still close to each other. And that's what generates a mapping where similar books are actually close to each other. Okay, so that was modeling with TensorFlow. If you want more details on how exactly this is done, I recommend chapter 17 in hands-on machine learning with scikit-learn, Keras, and TensorFlow. It has all the details basically, except for the secret. Yeah.
Yannick, someone in the chat asked, how does variational autoencoder relate to PCA, principal component analysis?
Right. Sorry. Okay, so principal component analysis is a linear method of dimension reduction. It maintains linear relationship between the input and the encoding. Okay, and that means that it just can't favor local relationships over long distance relationships. Okay, and there's just there's no way so it just makes compromises all the time. And we are really more interested in preserving similarity in the small scale, and we're willing to let go of similarity on a more larger scale. And that's exactly what a variational autoencoder enables us to do. It's not the only nonlinear dimension reduction technique, but it's a very, there's other advantages to doing specifically variational autoencoder and not regular autoencoders, but I don't think we have the time to get in too much into the details there. Okay, so that was modeling with TensorFlow. Then, as I said, I think it's really nice for data scientists to learn just a little bit of front end development. And I would say that the minimal amount of front end development that you want is you want to have some way to deploy your visualization as an HTML, so that you can give a link to people of your work and they can see it and they can run it in their own computer. And so what is Flask? Flask is a very simple Python app, Python package. You basically say, and the way that you should learn how to use it, I would suggest is you should learn how to just build an API. So you've got your data sitting in a database. You can query it with SQL, right? And then you want to provide your front end with a backend. And the backend is basically something that receives a query. In this case, for example, we want to know for a particular shelf, what are the tags? Okay, so if you go to the Galaxy shelf, and I need to say what shelf am I looking for? So that's question mark, and then shelf equals, and then science fiction, say. Let's see if this works. Okay, here, we got all the data, right? This was provided by this little bit of Flask API that I've showed you before. It received a request as /shelf. And in particular, there was a tag that was applied to it. And that argument was, which shelf are we looking for? Okay. And then it answers by querying the database, fetching the answer of that database, and returning it to whoever sent the query. Right, so that's a really easy way to get data out of your database and into a front-end app. Now, basically, the user has this JavaScript app that would run on their side, and they're issuing queries to your Flask server. That those queries are just rerouted as SQL queries to the database, and then served back to the front end. Okay, so that's a really small neat way to build an API. Yeah, makes sense. Okay. And then finally, I would say to actually build the visualization, you want to be able to play around with the visualization, and you want to be able to explore different visualizations. And it would be very neat if you can just play around with it as if it's a Jupyter notebook as well. And what you can get from Observable is at the end of your work, you can actually embed it back within the Flask API. So whatever we're going to go to Observable and see some of the stuff that I've been doing in Observable, but at the end of the work in Observable, I can just embed the stuff that I've done in Observable back into the Flask API. Okay, and in this case, all I'm doing is I'm serving some HTML, but that HTML is really a link to Observable HQ, which has all the stuff that I did in Observable. Okay, so now let me go to Observable and show you some of the stuff. Where is my Observable link? Over here. Okay, so here is the actual JavaScript is coming from this page. Okay, so basically this is the design of my app, and it's really just like a Jupyter notebook in a sense that it has cells, and each cell has some code. If I press on the left side, you can see the JavaScript code that's associated with that cell. Interestingly, unlike a Jupyter notebook, because this is JavaScript, there is no order of execution. All the cells get executed, and so you can have communication going not just down in the notebook, but also up. And so most of the code is actually in the next couple of pages. And by the way, the text that you're seeing here has nothing to do with the app that I'm doing. It's because I forked this whole thing from somebody else. Here's the original. Okay, this is the original visualization. The reason I used it is because it had the zoom that I wanted. And a smooth zoom like this cannot be obtained with Plotly. It can only be obtained by doing actually three-dimensional calculations. So you need 3.js. Now I don't know 3.js, but the code that was provided with this notebook enabled me to learn exactly the stuff that I needed to know in order to adapt it to my needs. Okay, and there's a community here that is amazing. I mean, you can go to explore, and you can find people doing like amazing visualization stuff, right? And you can easily fork their work, adapt it to your needs. And then what I'm suggesting is, after you've done that, you don't have to actually show people the observable. You can embed it within your HTML, and everybody can think that it's an actual regular app, right? As if you wrote all that JavaScript, and all you did is you took an existing app, you fit it with your own API. So the data is coming in from the API, and you're just displaying it in a different way. So let's see, where is it? I want to go back. So let's see. I'll show you how the data is coming in. The cell that is bringing the data is down there in the bottom. Where is it? I'm gonna find it eventually. It's a long notebook. There's a lot of, using 3.js in order to do two-dimensional visualizations just for the zoom, just to get a good zoom, and being able to put 200,000 dots on the screen. Like, that's not something that you can do in Python. That only real JavaScript can do that, and not even Plotly.js, which is faster than Plotly Python, is still not able to do that. Okay, so where's the data coming in? Let's see. Here it is. I'm just using a D3 query on my API, and it brings up all this data, right? This is the data that you saw being pulled before. This is what gets fed into another cell and produces the nice visualization. And then I'm just embedding that visualization within my Flask API, and I get end-to-end sort of full stack on a budget, I would say, right? This is like the minimum that I think you can do in order to be able to present 200,000 points on the screen and still have the zoom working.
So all you needed to do was just add your URL in there, and it did all the heavy lifting for you?
Well, there was a little bit more to adapt than that. I would say there was a little,
some massaging of the data.
some hacking that needed to be done, but but yeah, overall, I still don't know 3GS, right? I know how to tweak that original code, and I should say my capabilities in JavaScript are really basic. It's not like I'm a front-end developer. I don't understand promises yet, right? There's a lot for me to learn in JavaScript, but I was able to sort of hack my way through this, and that's the beauty of it. Okay, so we're 5 minutes before time. I think it's a good time for questions if people have it. That's my presentation.
Yaniv, back to dimensionality.
Mm-hmm.
You mentioned you arrived at 2 dimensions. You started with 333. Can you say a little more about the dimensions that you had at the beginning? And at the end, I'm guessing, were the 2 dimensions category and popularity, or am I missing the boat on the 2 target dimensions?
To a large degree, this is the outcome of the model. And the reason it's the outcome of the model, so it ends up being that this is a circular diagram. And it's a circular diagram because the algorithm is incentivized by the objective function to generate an encoding that ends up looking like a normal, 2-dimensional normal distribution. And the reason you're not seeing the middle is because these are books that are not so popular, and I've decided that, you know, I'm not going to bother you with them. But if we go and put the 200,000 books, the middle would fill out. There's a little hole here. It's because I'm pushing stuff a little bit out, and so I'm creating a little bit more of a donut shape instead of a normal distribution. So it will have like it'll be prettier. It's just aesthetic. And then what happens is the algorithm wants to make sure that it does a good job, and the stuff that's remarkable that it finds as something that doesn't have a lot of similarity to other things, it ends up pushing it out. Okay, but what are those things? Typically, those are very popular books, because the distance from a popular book to a non-popular book is large. The popular book has large tags on it, with thousands of people that have said that this is a good book to read. All the non-popular book, they look like a bunch of numbers that are very close to 0. So they are all similar to each other, right? And so the more the algorithm feels like it needs to provide information about the object, it pushes it out. And that means that away from the center is popularity, and around the center, the angle around the center ends up being more about genre, right? But that wasn't my decision. That's just the property of the algorithm. That's how the algorithm works. If we do this in 3 dimensions, we would get a ball. And the interpretation would be away from the center of the ball is more popular, but all the ball is just different genres.
And what about popularity being distance from the center versus, I thought it was also related to the intensity of the color. Maybe I got off track there.
So the intensity of the color is just a coloring scheme that we apply to the locations afterwards. We can read what was the original level in each one of these 333 dimensions and color the diagram accordingly, right? But we have to decide about the location, and the location is not specific to one dimension. It sort of embeds all the dimensions together. And so that doesn't change. Even when you change the coloring, the locations of each book are still the same locations. And there's situations where the algorithm has to make like a compromise. For example, plays are not very popular in general. And so all the plays fit in this little group over here. I'll show you. Where are plays? Plays. Okay, so you see this very small island, and that's because most people don't read plays that much. And so as a group, plays didn't get to be located far out. Of course, there are certain plays that do get read quite a bit. Maybe I should zoom in on them. And so there was an exception for Romeo and Juliet. Even though it's a play, the algorithm felt it has to push it out. And there was another exception for what is it? The importance of being earnest. I don't know that this is actually a play. Yeah, it is apparently a play. Okay, I don't know it. Anyway, but most of the group was located relatively close to the center because as a group they're not that popular. But look at what happens within the group. The more popular stuff is actually away from the center within that group. And that's typical. So all the Shakespeare plays are, maybe the popular ones like Hamlet, they are, within that group, they are away from the center.
Great. We've got a couple more questions here, I guess. Two of them, I guess one that I'll ask, how long did it take to scrape this data? I'm just kind of curious on that. And then also Daniel had asked, can we share this URL out, on Twitter and other social media stuff, or do you not want to have it overwhelm your server?
Okay, so on Twitter, I didn't think about that. That could be, no, this is pre-launch. Okay. So if you want to share it over email, yeah, feel free. I guess someone might put it on Twitter. Someone that you pass it to might put it on Twitter. So I guess I better make preparations already. Sure. But yeah, I'm not doing launch yet. I think I still need to work on this a little bit more.
Sure.
So.
Sure. Well, how long did it take you to get this data
then? Scraping this data is once you have the code ready, Scrapy does a very, very aggressive job. And so if you put it on a server, it would exhaust the resources of that server processing the data for you. These 200,000 books were overnight.
Okay.
So once the code is ready, it's not that long.
And they didn't cut you off. You didn't have to stop and restart it or anything. It just kind of worked.
Right, exactly. So I wasn't being polite. You're supposed to be polite, and I should have slowed it down. There was some refusals, and then I just reran with the refusals. Mm-hmm. Right. So I got everything that I wanted. But I wasn't operating in a recursive way. It wasn't like, here's a link, there's more links in there, just try all of them.
Right.
I was doing something that is more sort of every step it was a controlled step. So that's how I scrapped it.
Cool. If anybody else got a question, you can either post it here or hop off mute if you wanted to ask it.
Sure. I just had a question about, I noticed when you spin up the total books up to a very high number, there are still some deep white tranches between some of the outer edges. I'm just wondering, how would you interpret those?
Oh, that's very simple. When you say you only want 10,000 books, I'm giving you the 10,000 most popular books.
Sure. Okay.
And so those are out on the periphery. That's why bringing more books in actually fills in the middle, because those are books that are not that popular, and because they're not that popular, their tags are not so different from each other, and there's sort of this blob for the algorithm that it doesn't care about so much.
Sure. So when you spin up the total number of books in the result, right, there towards the outer edges, right, there are still some tranches. I'm just wondering what those represent.
Oh, okay. So
like there's still some white space there. Yeah.
Right. So the algorithm works with a little bit of noise between the encoder and the decoder. So it has to make sure that stuff that is different from one another has some separation. Okay. And so those are sharp boundaries between groups that are really different from one another. And that's really what creates this beautiful picture, right? Because even when you zoom in, you will still see like islands, right? There's islands and there's sub-islands and there's half islands, and you really get a topography here, and that topography is meaningful. I think we're looking at comics at the moment, and so I know that this area over here is more DC, but this area over here, this area over here would be Marvel, but this area over here would be DC. Okay, and so these islands, they really mean something. Like all of this little island over here, that's all Asterix and Tintin, right? So these kind of French kind of comics. So all of this is meaningful geography that is being generated. And I call the site See the Galaxy because, we're stuck on this planet. We discovered all of the planet. Like, people that want to explore spaces that haven't been discovered yet have to go to the bottom of the ocean these days, or they have to go to space. But there are dimensions that we haven't explored yet. So our data provides lots of dimensions.
That's lovely. Thank you for taking my question.
Yeah. Anybody else? We're good.
Does this have anything to do with the author name at all, or not really? It's just more the genres straight out.
That's actually a control. So I didn't put in the author name. Now, there are authors that are so famous that their tags made the cut. So if I go to Tolkien stuff, if I find it for a second, where is it? I think it might be over here. Anyway, Tolkien has a tag. Okay. Because it's so famous that people use it as a tag, and they can use
I see it there. Adventure
they can
Tolkien.
use it on stuff that isn't Tolkien. So, for example, Jane Austen is very, very famous, and there's a Jane Austen fan fiction tag, right? And it's a branch of literature. Anyway. Yeah. So all I'm saying is there's not many authors where they have a tag associated with them. Tolkien is one, Stephen King is another one, but generally they didn't make the cut. And so if you see a collection of dots all written by the same author, it's because people applied other tags in a similar way to all of these books. And that is what drove them together. And so this is, for me, it's a control. Like I can sort of use the fact that I didn't put in author tags in order to verify that the algorithm is doing a good job with the other tags.
That's neat. Yeah. It's the sort of I guess it's the visualization and the grouping that you don't see when you just go to Goodreads.com. Right. Exactly. As you're going through Goodreads, you're not going to understand these types of tags. So now that you've scraped it and pulled it together, you're able to now get this huge tag list and be like, oh, this is interesting. There's tags for Tolkien and whatnot, which wouldn't be easy to find when you're just sort of browsing through the site.
Right. I mean, to some degree, you can say even just a list of tags to search. I mean, each one of these tags, you can run it in Goodreads itself, and you can see what Goodreads has to say about each one of these tags. And so just providing a clean, because Goodreads mixes up tags that have nothing to do with genre, with tags that are genre related. For me, just getting a nice clean list of just the tags that are genre related, was a nice achievement. I really enjoyed that. And then you can, I mean, all these tags are available in Goodreads, and you can explore them by yourself. But they're also here, right? They're all here.
Yeah.
So maybe back to product dimensionality for a second. Jan, have you ever heard of TRIZ, T-R-I-Z?
No, what is that?
Not a test, just curious. So Russian acronym, it's a tool for systematic innovation. There's lots of genres of systematic innovation. Happens to be a Russian who invented it, really going back to the late 50s, early 60s. It stands for Theory of Inventive Problem Solving. And it's basically a set of 40 inventive principles that are used to solve a problem. He actually looked at the Russian database at that time and classified every patent, 200,000 I think it was, on the basis of which inventive principle that they employ. And again, it's kind of back to that notion of, is there a way to discover the next product using a technique like TRIZ, or there's a guy at and this guy spoke at Mini Analytics, I'm going to say a couple years ago, and his name is Joel Martin, and he's at NRC in Canada, which is the equivalent of NSF for us, and he was looking at AI-enabled product design, and maybe just adjacent to that notion of systematic innovation, looking at product dimensionality. They were qualifying or classifying products based on the technology that they were using and laws of physics, what's possible, what's not possible. And they were aspiring to do that sort of thing, identify like the next product, what problem hasn't been solved, or what problem that can't be solved hasn't been solved.
I think this is a very, very deep issue, and it has to do with curiosity. What is curiosity? As far as I can see, is the exploration of space that you haven't visited before.
Yep.
Right?
Yeah.
And so to be able to model the density of a space enables you to know where you want to go. The places where you want to go is the places that are in between, the places that, are not so easy to get to. If we're talking about, designing a robot to explore the room and making sure that the robot actually learns all the room, right? So it needs to somehow figure out low density, in its own experience, in its own, the spaces of it, the space of its memories, it needs to figure out where are the low density.
Nice.
Right. So that has to, innovation is curiosity applied to coming up with useful stuff.
Very nice analogy, thinking about the robot exploring the floor. So in a way, what you have is a product discovery robot, or you could frame it as a product discovery robot. How can you identify the part of the floor that hasn't been vacuumed yet, or
exactly the part of the product space that hasn't been built yet. Right. Yeah.
Call it the Roomba technique. Yeah.
Nice. Very nice.
Exactly.
We're riffing now.
Yeah.
Will you share your contact information with us, or would we overwhelm you?
No, yeah, I haven't. Okay, so I am Yaniv Ben-Ami, and my primary tool is LinkedIn. So if you put Yaniv and me on LinkedIn, you know what? I'll put it in the chat now. Where is my LinkedIn? Me. View profile. And here I am. I'll put it in the chat. And I would be super interested in, you know, continuing this conversation. This is very much very productive for me. Yeah. Here's the chat. Here's my link. Shoot me a contact request. I would be super happy to connect with anyone, even remotely interested in any of this.
Yeah, I was also gonna say real quick too. I'll drop in the link to the deep learning study group.
All right,
as well.
Right. We need to advertise that.
Definitely,
Thank you.
definitely plug that. So yeah, it's a great group, and I try and attend when I can. But yeah, every Sunday, even a couple of people that are on here tonight, I think, get together and go through different books.
Yeah, we're currently doing reinforcement learning. Cool stuff. But afterwards, I think we'll do parallelizing the computation of neural networks. So that's the plan for approximately the next 4 or 5 meetings, is finish reinforcement learning, then how to parallelize the solution of deep neural networks.
Awesome. Well, great. If there's not any other questions or anything, I want to thank you for sharing all of your research you've been doing, for all just sort of giving back with the Twin Cities Deep Learning Group, and just your knowledge and sharing both, you know, here and also I know you did some other. You presented earlier on this year or last year, I guess, in 2020, when we were doing some COVID data analysis too as well. So I thank you very much for stepping up and sharing your knowledge with the group. It's just been really, really cool.
Thank you. Thank you for inviting me. This is an awesome group. I'm very, very pleased to present here. It's amazing.
Great. Well,
Thank
cool.
You, for organizing. Justin.
Thank you, David.
Sure.
And thank you for your comments. These are very insightful stuff.
Thank you.
We'll see everyone next month.
All right.
Bye-bye. Thank you.
Bye-bye.
Bye-bye.